On the 20th of September, I made this meme. It's a rectangle with an area 51, but also a perimeter 40. I made it for the raid. And it got me wondering if I could make a rectangle with an area and a perimeter of 51. Before we go any further, every length is measured in units and every area is measured in units squared. So I start off by equating the formulae for area and perimeter of a rectangle, so AB equals 2 times A plus B, and then I manipulated that to get B equals 2A over A minus 2, so now we know the relationship between the two sides. Going on, we're going to assume that A is greater than or equal to B, so that's the longer side, unless they're the same and it's a square. So since area is AB, then it's going to be 2A squared over A minus 2, which I rearranged into a quadratic equation, and then using the quadratic formula, got the side length of A to be A plus the square root of A squared minus 16A over 4. Side length B is just A minus the square root of A squared minus 16A all over 4, and this makes the side lengths of our rectangle 51 51 plus or minus the square root of 1785 all over 4, which ain't pretty. So let's find some pretty cases, some cases where the side lengths are rational numbers. For this, the square root of A squared minus 16A must also be a rational number, so let's call that D, making A squared minus 16A D squared. We can rearrange this into another quadratic equation, and applying the quadratic formula again, we get the surface area to be 8 plus the square root of 64 plus d squared. Now that will be a rational number, only if 8 squared plus d squared is another rational number squared. So it looks like now we've got to crack open the Pythagorean triples. But before we go any further, let's have a recap. By setting the area and perimeter of a rectangle to be equal, we create a relationship between the two side lengths, and that allows us to work out what they are in terms of the area slash perimeter, and if we want them to be rational, this term here must be rational, which means that this term must be a rational number squared. Arranging that into another quadratic equation and applying the formula gives us an expression for the area, and since it is rational, this must also be rational, specifically the hypotenuse of a rational Pythagorean triple containing the number 8 and this term from earlier. So let's find some triples then. 0, 8, 8, 6, 8, 10 and 8, 15, 17 are the only whole number Pythagorean triples with 8 in them, but if you take any other triple and multiply all the terms by a rational number such that one of the terms is then 8, then you immediately see that there are countless Pythagorean triples of rational numbers where one of them is 8. Adding 8 onto the hypotenuse of a triple gives you the area such that the side lengths are rational. Since only 3 of these are whole number triples, the only rectangles where the side lengths are rational and the area and perimeter are the same whole number are the 4x4 square, the 3x6 rectangle, and the 2.5 by 10 rectangle. Interestingly, with aspect ratios of 1 to 1, 1 to 2, and 1 to 4, respectively. But what if we want an aspect ratio of 1 to n? In this case, the side lengths will be a and na, so if area is perimeter, then na squared is 2a times n plus 1. Since a is not 0, we can immediately work out that a is 2 times n plus 1 over n, making the area 4 times n plus 1 squared over n, since that is na squared. Interestingly, this means that for any rational aspect ratio, we get a rational area. So for a 1-3 aspect ratio, an 8 by 2 2/3 rectangle has an area and perimeter of 21 1/3. That's all fine, but we still haven't got our perimeter 51, and I would quite like to have a perimeter 51. So I thought, how about a different kind of shape? A bunch of unit squares shoved together with an area and perimeter of 51. Is that possible? No it's not. But here's why. The unit square has a perimeter of 4. If you add a new square and it touches one side, the perimeter goes up by 2. If it's touching 2 sides, the perimeter stays the same. If it's touching 3 sides, it goes down by 2. And if it's completely surrounded by 4 sides, then the perimeter goes down by 4. This means that the perimeter is always an even number, and 51 is not an even number, so it can't be done. Although you can do it by arranging 204 quarter unit squares into a shape that has a total perimeter of 102 half units, which is exactly what I did. Here it is, area 51. In conclusion, maths is pretty cool. We had a problem in geometry, we explained it using quadratic equations, and we solved it using Pythagoras' theorem. Anyway, thanks for watching. I really like this kind of video where I have a challenge, I overcome it, and then I show you my thought process for working through it. So if you have any challenges you want me to have a crack at, put them in the comments, I'll see it, so why not give me something to do? And I'll see you in the next well thought out video / shitpost.